Do you have a lot of plastic bottles inside your house? How about plastic bags? How much plastic waste do you think you consume weekly?
A lot, right? Well, according to the Global Alliance for Incinerator Alternatives, the Philippines consumes around 60 billion sachets of plastic per year.
The amount of excess plastic bottles that are thrown or sold at junk shops has been observed by the researchers. Thus, the researchers were inspired by the idea of repurposing these unwanted plastics to something useful.
The researchers found studies showing that plastic waste increases as industrialization advances. Thus, the researchers view eco-bricks as a solution and a compromise between plastic waste and rapid industrialization.
I am Hans Campomanes.
And I'm Charlemagne Angelo, and we will be discussing Ethylene experimental research,
The use of polyethylene terephthalate plastic as an expensive and sustainable material for eco-brick production. We are at a time where industrialization is reaching its utmost capabilities. Construction alone is considered as one of the most critical skills needed to accomplish such progression. Many inventions were made, many trials and errors were performed to provide ease of living for society. While these creations did well, most, if not all of them, poisons the environment, which is the raw material and the source of all future projects. To help in this issue, many try to incorporate nature more into their projects. For example, solar energy, hydroelectric power, biomass, etc., which in this case are eco-bricks.
What are eco-bricks? According to Google, an eco-brick is a plastic bottle packed with used plastic to a set density. These serve as reusable building blocks. However, in our experimental research, we put these plastic bottles filled with plastics into concrete, creating a solid brick. We have decided to do this method as a way to make eco-bricks stronger.
The researchers aim to provide building bricks at a lower cost while also helping reduce waste in the environment. This will be made possible by using the PET bottles that are littered almost everywhere and provide an eco-friendly but durable construction material. This study aims to answer the following questions based upon the researchers' view about the use of polyethylene terephthalate plastic as an expensive and sustainable material for an eco-brick production through their experiments, which can be seen on their products. The questions are: 1. Is the product strong enough to be used as an alternative for common construction materials? 2. Does the product help reduce polyethylene terephthalate plastic waste? 3. Can the product be a substitute for standard construction bricks? In addition to this, is the product cheaper than standard construction bricks? And is the product more recommendable than standard construction bricks?
In order to answer these questions, the method used was experimental. Experimental design is the process of carrying out research in an objective and controlled fashion so that precision is maximized and specific conclusions can be drawn regarding a hypothesis statement.
The researcher collects data and results that will either support or reject the hypothesis. This method of research is referred to as hypothesis testing or a deductive research method. Generally, the purpose is to establish the effect that a factor or independent variable has on a dependent variable, which in this research can be classified as the result of mixing in PET plastics and producing eco-bricks.
We can now proceed on what materials are used in the eco-brick, how the eco-brick was made, and what were the data gathering procedures used.
The materials used in making the bricks are 1.5 Coca-Cola bottles filled with plastics, an open-top mold with inner measurements of 20 centimeters in height, 40 centimeters in length, and 6 inches thick. Concrete was also used. The ratio of cement to sand is 1 part cement for every 4 parts of sand, mixed with water until the mixture is neither too wet nor too dry. In the making of the brick, the mold is laid on a flat surface. The mixture of concrete is poured in the mold until it reaches the height of 5 centimeters. Then, the 1.5-liter bottle filled with plastics is placed in the middle. When the bottle is placed, the mold is again poured with concrete until it is filled. A plywood is placed on top and the mold is flipped upside down so that it will be easily removed. The mold will be immediately pulled off to prevent the brick from sticking to the mold and the eco brick is left for 12 hours until it is solid enough to be handled. During the drying period, the brick is periodically poured with water to maintain its moisture and temperature. The data gathering procedures used in this research are soundness test. It shows the nature of bricks against sudden impact. Absorption test. It is conducted on the brick to find out the amount of moisture content absorbed by the brick under extreme conditions. The difference between dry and wet brick weights will give the amount of water absorption. For a good quality brick, the amount of water absorption should not exceed 20% of the weight of dry brick. Compressive strength test. It is determined by placing the brick in a compression testing machine. As an alternative to the lack of equipment, the researchers used a different method accordingly. The researchers used their own weight to measure the maximum weight capacity. When the brick breaks while handling a number of people, then the sum of the weight of all those people will be the maximum force that the brick could handle. Hardness test. A good brick should resist scratches against sharp things. If there are no visible marks or scratch impressions on the brick, then it is said to be a hard brick. Cost calculation of eco bricks. To see if the eco bricks were cheaper than hollow blocks, the researchers used the following formulas to calculate the cost.
At the end of the experimenting period, the researchers gathered the needed data. Here are the results on the data gathered. Soundness test. The brick was hit with a hammer several times. This produced high-pitched sounds and proved that the brick can endure being hit by a hammer with a lot of force without leaving a dent nor a crack. Absorption test. An eco brick weighing 15.8 kilograms was submerged underwater for 24 hours. Once the 24-hour period was done, the brick was pulled out of the water and weighed once more. Its weight increased up to 16.4 kilograms. Now, having two values, you can find the percentage of water absorption. The percent of the water absorption is 0.0038%. Since the percentage of water did not exceed 20%, this test proved that the brick was not water absorbent. Compressive strength test. Due to the lack of equipment, the researchers summed up their weight, which is 325 kilograms. After summing up their weight, they all stood on the brick to see if the brick could handle the pressure of 325 kilograms. The eco brick managed to withstand 325 kilograms. Hardness test. To test the hardness of the brick, the researchers used a hard knife to scratch the surface of the brick to see if it would leave a scratch. After the test was done, the brick was examined to see if the knife left a scratch. None were found. Cost calculation of eco bricks. To see if the eco bricks were cheaper than hollow blocks, the researchers used the following formula to calculate the cost, given that both the bag of sand and cement weighs 12 kilograms. A bag of sand costs 30 pesos, while a bag of cement costs 40 pesos. To get the cost of the sand and cement per kilogram, their costs per bag are divided by their weight. Using this said formula, the researchers found out the cost of sand is 2.5 pesos per kilogram and 3.33 pesos per kilogram for the cement. Considering the ratio of 1 to 4, which is 1 kilogram cement to 4 kilogram of sand, the prices are multiplied to the ratio, which is also multiplied together to represent the mixture and the price of the brick, which is 33.3 Philippine pesos. And to conclude and answer the questions from earlier, we have Castor Ramos to discuss it.
In conclusion, we were able to identify the following. Number 1, the researchers' eco brick was capable of carrying up to 325 kilograms and is expected to be capable of carrying over 500 kilograms. It was bashed with a hammer without leaving a dent, then scratched with a sharp knife without causing any damage to the surface. Number 2, the eco bricks help reduce polyethylene terephthalate plastic waste by filling up a 1.5-liter Coke. Bottled to the brim, 500 grams worth of plastic was what it took to fully fill up a 1.5-liter bottle. Number 3, the product is worth 33 pesos, which is more expensive compared to 20 peso hollow blocks. But it is heavy and dense in nature, making it suitable as building material for military purposes, roads and sidewalks, or local projects by students. It is a viable substitute if one wants to build strong and durable surfaces. Now, these answers may not satisfy some of you, but we believe that this study will be helpful in the near future regardless of the result. It will open up possibilities for the next researchers to discuss, adjust, or enhance. The bonus is that all of this is achievable without the need for special machinery or skills.
To discuss our recommendations, we have Angelo Regis.
We recommend the following when planning to make an eco brick, and hopefully it gives you better results.
Use a different ratio that uses less cement compared to sand. Use a smaller bottle to produce a smaller brick with the dimensions of 240 mm by 120 mm by 70 mm. A smaller brick would have more flexibility in construction and could be carried easily. To the researchers who would want to expand this study, they must get access to a hydraulic press to accurately test the compression capacity of their brick. Explore more methods on the creation of various variants of eco bricks. Usage of this specific version of eco brick on sidewalks and road projects. Usage of this specific version of eco brick on local school projects such as outdoor benches and tables.
We now hope that you have a deeper understanding of our research in this video.
And that concludes our research presentation. Thank you for watching.